This is Euclid Book 11, definition number 27. And this is an icosahedron. Well, as best as I can draw it with the limited equipment that I have. I would have used my dry erase board, but my compass was just too darn big to draw this. So I went ahead and bought extra large graph paper and drew it this way. And I did whatever I could to draw this by Euclid's instructions, which were very intricate to say the least. Now, this is actually drawn in Euclid Book 13, proposition number 16. Okay? And we will draw it, and I will show you step by step how to do this in Euclid Book 13, proposition number 16, and I will show you how to do that when we get there. Okay? Right now we're just going to define what an icosahedron is. And the definition reads as follows. An icosahedron is a solid figure contained by 20 equal and equilateral triangles. Now what that means is that all 20 of the triangles are equal in area and they are also equilateral. That means all three sides of the triangles are equal in size. That's what the definition is. Now you say, well, how in the heck am I going to draw this thing? Well, first of all, you're going to start with Euclid Book 4, proposition number 11. That's right, you're going to have to draw a pentagon inside of a circle. You're going to have to inscribe a pentagon into the circle. And that's why we have E, F, G, H, and K. Okay? And then, eventually, you're going to end up drawing a second pentagon with letters Q, R, S, T, and U. That means you're going to draw two circles, two pentagons, and you're going to draw a whole bunch of lines. And I'm going to give you clues as to how to draw this thing if you ever decide to follow Euclid Book 13, proposition number 16. Keep in mind that triangle QUZ is equilateral. So is triangle LMX and triangle LMR. Now what does that mean? Okay, well let me show you. If we have triangle LMX equilateral, then this is L, this is M, and this is X. That's how you're going to find point X, right there. Now, you say, well, what about point L? Okay, point L is going to be on this great big circle. This is also circle E, F, G, H, K, and L is going to be on that circle. So, when you bisect EF, you're going to put the bisect point down here and you're going to call it L. Then when you draw LM, you're going to draw two other lines, this one here, which is MX and LX, and both of these lines are going to be the same length as LM. And you could do this 5 times over. Isn't that neat? Okay. Now what about LMR? Okay, well here's L, here's M, and down here is letter R. L, M, and R. And all three of these sides are going to be equal in length. Oh, what about Q, U, and Z? Well, this is how you're going to find point Z. You're going to draw a line from point Q to point U, and as soon as you draw that line, then you're going to draw it over here to point Z. I know it looks like an N, but that's actually a Z right there, because N's way over here. So this is point Z, and if you do that, the length of QU is going to be the same length as QZ and UZ. Now you say, well, how do I draw an equilateral triangle? Well, do you remember back in Euclid Book 1 where Euclid taught all of us how to duplicate triangles? Well, that's what you're going to do here. You already know the length of all three of the lines because the lines are all equilateral. So, you just put a point way out over here, a point way out over here. Okay, you put a point out way over here and a point way out over here, and you're going to cross them together, and that's how you're going to get point Z. So that's how you're going to do that. So as you can see, most of this proof will not be too hard to draw. The only line I really found hard to draw was VW. And that was hard to draw because I couldn't exactly find point W according to his instructions. And we will cover that in a future lesson. But the definition of an icosahedron which that's what this is it is a 20-sided figure. All 20 sides are triangles. The area of all 20 triangles is equal, and it's also equilateral. Every one of those triangles will have the same, it will have the sides the same length. And that's what he's trying to define here. Now, on my next proof, I will show you how to draw, well, I won't really show you how to draw, but I will show you a dodecahedron. Then after that, we can start going into these Euclid proofs from Euclid Book 11 onward. You're in for some treats, I'm telling you that. So, I hope you enjoy this presentation. I thank you very much for tuning in. You have now seen the basic foundations of an icosahedron. You now know basically how to draw the thing, or as best as you can anyway. Alright, I will tell you more in a future video, so I want you to stay tuned.